Basically, this is digital earth resistance box. So with this box, we'll just find the resistance of the earth or any unknown resistance of any unknown conductor, or just we can find the resistance of anything which is a conductor, which has some resistance. So we have three types. See, this is first one, second one, and third one. And first one is for we'll have four electrodes. We'll just make a hole in earth and we'll just place it. And the second one is that we'll find the resistance of earth pit. That means we will do earthing. After that we'll find the resistance of that earth, that rod. And the third one is that I already told you that we can find unknown resistance of any material. So third one is about that unknown resistance. Electrodes. We'll have four electrodes. We'll just connect this to E1, P1, P2, E2. E1, E2 we are nothing but we are just passing the known current. We have to give the current that which is sent using this meter, and the potential difference between two points, that is P1 and P2, will be calculated, and the meter gives us the resistance of the earth. And now we need to place these four electrodes with equal distances in a straight line. I am taking 1 feet.
ఇట్లా
Now the thing is that hammer the electrode until we see until this depth. That means only this part should be visible and remaining part should be in the ground. We have done with the four electrodes into the earth, and now just connecting four different colored wires. See, this one is yellow, black, red, blue, and I'm connecting four different terminals. One is with the yellow, and this is with the black. And this is with the blue.
వస్తుంది
And this is with the red. See, we are just passing known current with these two terminals, and these 2 points are just like we are finding the potential difference between 2 points. Those 2 points are P1 and P2, and these two are E1 and E2. Just we'll connect these terminals to earth resistance box. You already know it. This is earth resistance box. See, yellow is E1, red is E2. So just connect. And the red is E2. E1 and E2 are the corner terminals, and P1 and P2 are the potential points through which we find out the potential difference.
Start.
Here it is already charged, so no need of power supply. If it is not charged, that is if it is either new one or if the charge of this meter is completed, that means if it is totally discharged, you can give the power supply directly. And as it is charged, it itself gives the known current, and the potential difference will be calculated to 10 ohms, and if it just press the test, we'll get the resistance, and it is about 9.7879 ohms. And if we that means if we take to a level of 100 ohms, it is giving about 13 or 14. That means very less resistance. So actually the resistance, that means earth resistance is the suitable earth resistance where earth pit can be placed is almost, for houses or independent houses, it is almost about 5 to 7, and for an apartments like apartments or like an industries, it is about 3 4 2 to 4. And when we come to railway stations or high voltage areas, it is about 1 ohm. 1 ohm generally railway lines will be having an earthing of 1 ohm resistance. If it is above path, that is above 1 ohm, something like 1.2 or 2, if it even if it is 2, they'll not make that earthing, they'll just change the earthing. Found out just now we did an experiment, or we did just to find out the earth resistance, and now this is generally earth pit. That means we already did it, because now it is there is no time to do again. How we did this earthing is that we just dug a pit of 2.5 feet in the length, width and depth, that is in the form of a cube. So after that we'll just in olden days they'll be going with charcoal, salt, sand, but it is getting complicated to do that. So nowadays we are coming with a new chemical that is generally used for earthing. We first dig up to 2 feet depth and length and width, and after that we place some chemical, and we place this rod, and we threw that chemical into the pit, and then after finally we covered it with sand, and we started pouring water up to 1 week. Generally we need to water it because the resistance of the earth may vary, so if we keep on watering that when there is no power, the earth resistance may be constant, that means it may reduce the earth resistance. And now we are doing the earthing, that is whether the resistance of this earth pit is good enough to make an earthing or not. Similarly, just in the previous we did with 4 electrodes. Now we are doing with 2 electrodes and one is earth pit, and we are just short circuiting one earth E1 and P1, that is potential point and the current point. We generally do that. I am considering black and blue as E1 and P1, because black and blue are connected to E1 and P1 of the meter. And the important point is that this earthing rod will be galvanized iron, so that it will not rust. It is short circuited, and these two, that is this is P2 and this is E2. These two will be placed with a distance of 1 feet each from The wiring part is done, and just we need to check what the reading it is giving. So I already told you that E1 and P1 are short circuited at the earthing rod, and P2 is blue wire, which is the second potential point, and E2 is the other current carrying electrode. Just we connected that, we are taking into 10 ohms, and we'll just test it. It is giving about 19.4 ohms, which is totally not at all suitable for earthing. So this is how we find out the earth resistance and how we just do earthing. So at homes, if we have any any earthing, we can make our own earthing with the help of these electrodes and with this earth resistance meter. That's for this experiment.